Have you understood that macro processing completely, or do you still have some questions? Can you hear me?
Yes. Yes, sir.
Kanchan, where is she there? Seems not joined. Okay, so any questions with respect to the macro preprocessing? Kanchan, you asked some question, or I could not understand whether what you tried to communicate to me, whether you understood it or not. Can you please clarify? Kanchan, can you hear me?
Yes, sir.
Yeah, so let me know what your queries are so that I can address it again.
I understood it, sir.
Okay, okay. Any question for others? Rather, like if you have any question about macro, then you can let me know. I will write. I will take 2-3 examples again for today's case, so as to understand more deeperly how that happens. Okay, so we'll try to write macros, but then we will see what exactly happens when you write a macro. Correct. Then when macro call is executed, what happens? So as we stated there that day, like macro processing would be treated as pass 0 by the NASA assembler or generally any assembler. Okay, so what it does, it reads first or it collects information about macros by adding its information into macro name table and macro definition tables. Fine. And then appropriately, like it enters into its own second phase where it expands each macro definition. Second phase, I mean to say, see, that day we saw like if at all a macro is to be defined, it should be defined prior the call. Okay, so let us take another example. Sorry. Emacs. So you write first percent macro factorial say, and we are going to pass two parameters. Second would be holding the data. Correct. Second would be holding the data. So we say move ex comma 1, move ECS comma %1, mul ECX XOR EDX comma EDX loop LP and LP is here. So as we are using a local label, that's why we will use %%. This is for if you are going to call macro more than once, correct? And then move d word of %2 comma ex and % macro. Okay, this is how your factorial calculation is. You can, I think you can see like what I did was I am trying to compute factorial. Okay, in this case. So now let us write section dot data mhg db factorial is factorial of percent d is percent d section dot global main extern scanf printf push n call push read1 call scanf add esp comma 8 factorial. I think we give name factorial factorial of n comma fact push fact push n push msg call printf add esp comma 12. Fine. So let us see first whether this code works or not. So nasm dash apl 32 gcc dash m32 okay. So yeah, so actually it is waiting for your scanf. So if I give 4, then like we have to make a change. It is printing that address of both the values. So one change is required in the code where we'll write the word of fact, the word of n. NASM GCC. So we get 4, we get 6, we take 7, we take 8. Correct. So you can see now the code is getting executed. Now let us try to see what happens in the processing. So if I try to generate, say, or list variables, I can see that these are the ones which are declared by me. Okay, there is D as well, read one. Okay, in data section, msg n and read one as message. Okay, one. We have another percent D written there. Okay, in the message along with message. So that was for read one. And let us try to see whether can you see fact there. Yeah, you can see fact. So all of them are organized in terms of order of characters. Okay, in some sorting order. Right. So we can see like if I take this nm as well with 0 parts do, then you can see my label also is added there LP. Though I requested only once or I called it only once, but it is showing me that it automatically converted it. Now, if multiple occurrences of symbols are there, labels, I mean to say, how to take care of that fact. Now, you cannot have your own data section for macro. Correct? You cannot have your own data section for macro. So let me see if I can do something like this. So it says what? Uninitialized space declared in section dot data non BSS factor. So it was because of line number 14. Okay, because we added that dot. Correct, line number 14. So if I try to define local variables, I cannot do that directly. So how there might be some provision provided by some assemblers, okay, where they may permit sometimes like making use of some local variables. Correct. Now where the local variables possibly could be. So let me try to show you how exactly your linker works out. So let me write a simple code 0.0/2022.c. Correct. And let me write main. How these local variables are tackled, that's what I'm trying to tell you. Now those local variables are not defined by you. Okay, please note this. It is defined by the system or the translator or probably the loader or linker, depending upon wherever the stage is. So if I write the integer a, so if I say printf enter value, /n scanf %d ampersand a, correct. And now printf the square of a %d is %d. Fine. So this is a very pretty simple code that we wrote here right now. Correct. What exactly it is doing? It is trying to probably display square of the number given. Correct. Written in C. Okay, written in C. So let us come out of the code. Let us try to translate this. So GCC 0405 underscore c.c dash m32. Okay, it is because of function. So if I say 4, I can see the square. Correct. Now, if I write nm a dot out. Now it is using putS, printf. Have I used putS there in my code? Check whether have I used putS there. So 0405. Have I used putS? I used printf twice and I used scanf. Am I right? But when I try to see the symbols listed for my file or executable that got created, it started with BSS, data start, and so on. And then I can see there is printf in text section, there is putS, which I haven't used. Correct. And there is a scanf too. So if I try to execute this through strace, this is for system calls. So what is the internal function or interrupt used when your executable got executed? You can see it entered this, wrote this right. OK. Enter value slasher. Correct. And then I have read. So I'm reading the values. So I'm giving 4. I can see that another write is there. So 2 writes are used because my printf is there. So what are the language that you are using? What are the print function that you may have included in the appropriate language or other part of language? Pick any example, say Java, C, Haskell, wherever there is a printf. When the code is executed to be executed at machine level, always this write system call will be given a call. Correct. Write system call is given a call. Now, in library, you may have printf defined in different mechanisms. Say, for example, if I write man3 printf, this is the print function that is available with your C code. Sorry, C library for Linux programmers manual. Printf, F printf, D printf, S printf, SN printf, V printf, VF printf, VD printf, VS printf, VSN printf. So many things which we never really used. I hope most of you must have used these two. Am I right? Correct. And if you see even the parameters defined, some print functions are having restricted number of parameters and some printf functions are having unlimited parameters which are mentioned with dot dot dot. You can see the first set which I have chosen now. Okay, which I'm showing you right now. This one is without knowing how many parameters are, and this seems to be fixed number of parameters. Probably we don't know. Even including this. Right now it seems so. Now this it says feature test macro requirements for glibc. It may make use of these as an macros too. Something like this dprintf, vd printf. We don't know what exactly they are, but it is a family of print function. And that's what it says below. The function in the printf family produce output according to a format as described below, depending upon which kind of printf you are using. The functions printf and vprintf write output to standard output. Correct. That's what we use. fprintf, vfprintf write output to the output stream, which is mentioned either with file pointer or file number. And sprintf, snprintf, vsprintf, vsnprintf write to a character string str, which is mentioned as a part of your call. Now user may use either of those functions, but internally this printf, whatever the format, whatever the family of printf function is, it would be replaced by write system call only. Same thing if I see with puts. This is a family of functions. F put C, F put S, put C, put char, put S. Now if you see their parameters too, some of the parameters seem to be same. Only change is whether you are having a string or whether you are having a character. Now we don't have something called as, or rather if you see F put C, this one, sorry, this one and this one, you will not see any change in the form. Both of them are doing the same thing. But when we use putchar or f put C or probably put C, it says writes the character C cast to an unsigned character because you are passing a number. And our habit of Turbo C compiler was we used to make use of getchar and putchar with character to be the parameter. And it will be kind of difficulty for us rather to handle such kind of things. So like there could be thousands of programming languages. How an operating system should cope up with those all function calls. And that's the reason it has set of probably interrupts. So if you go here and if you check this file unistd32.h, this contains all system calls or function calls internally used by the system. So you use fork as a function call probably to create a process. Like once in one of the chat on WhatsApp, I assume I have shared one playlist for an operating system course, which was conducted by me last year. So few sessions were there included as a part of. So if you haven't received, let me know. I can add that. Correct. So if I see that, like how exactly internally my functions are organized, my system calls are given call to. How exactly, what exactly happens there? Correct. If at all I have to use it, what strategy I should make use of? So I'm adding that channel probably like in chat window. Those who haven't used yet or seen or used, say for example, fork system call, we can see those things, introductory part of it through the chat window. Okay, I have added this YouTube link, and this may help you to see really what happens at that end. Like whenever I'm talking about process state diagram and so on. Now you may say, why do we require to talk about it into system course? Everything is dependent. Exactly. Because your operating system itself is one kind of system program. And which is helping you as a user, you are acting as a user. So operating system is helping you to execute collectively, smoothly the operations that you wanted to execute. The operation you really wanted to execute. So like if these are the system calls used, there are so many things, like nearly to 300 something. Yeah, nearly 435. This is for 32-bit. Let's see the path that I included on my OS. In this directory, you should see this one. UniStd.32. So if I use 64 there instead of 32, then I would be getting system calls for my 64-bit OS. And they are much more now in some form rather. Whenever we are trying to deal with these all, you can call it as interrupts or system calls, and they would be similar to what we saw with the 32-bit operating system. Okay, you can see same number 435, but make a note here that the numbers they are used to represent here in front. Can you see the number associated with every line? See this. So read it as 0, write it as 1, open it as 2. This is a system call number. And if I see this, we had restart system call 0. Read was at 3, which was in 64-bit considered as 0. Considered as 0. So if these system calls are going to be used internally, what kind of care should be taken by the system? Because it may require the function calls to be translated to exact what you can call it as the system call representations. For say, for example, when I executed this command, this one, you may see there are multiple system calls: mmap, 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 close, set thread area, mprotect, fstat, brk, brk, brk. What they are exactly? They are the ones which are organized by the system internally. Now see, even your printf, how exactly enter values of A and B. So 23, enter values of A and B equal to 23. So if I count this size, so I got 1 here. Okay, with read, with write. With read I got 0. So they meant for standard input and standard output. So 1 means for standard output and 0 means for standard input. I exactly can see that data to return into this file. Sorry. Now in include directory, not in ASM. So you should see standard input and standard output numbers written. Yeah. See. So your system is some way integrated or hands to hand working together in an integrated manner. So your compiler takes help of OS, your loader takes help of your OS, your linker even takes help of your OS. So ultimately, OS would be playing an important role in the system. Correct. Now, our questions still remain unanswered. Why printf and putf was used as a symbol there? Correct. So if I write that nm, I should be able to see printf and putf there. Now putf is gone. Earlier it was. Correct. Earlier putf was shown to me. Now putf is not used. So sometimes your system can take call whenever you are recreating the executable after execution of the code, probably whenever you don't have any formatting parameters included in the system. Like for example, %d, %c, %s, %f in printf call, then it would be replaced by put s, which is very easy for it to make use of, because anyway it would be using internally write system call. Both the printf calls written in the code were replaced by write system call. So now let us try to see where exactly my local variables are. So now let me go to that thing and let me write here. Let me generate an assembly code by writing, sorry. Sorry, cd is 2. Yeah, I used, I think, wrong file there. So you should see printf and puts here. Yeah, printf and puts. I think I opened a wrong file there, which was not in the current directory. So this is the one which we were talking about. One putc would be used when there is no thing. So when we said enter value for A and B, actually it is for puts, the write system call. Okay. Now let me generate this assembly code. So ls-ltr, sorry. Let us open that code 0405. Now see how internally probably your system is renaming or creating a set of variables. Now enter value, when I said enter value, this was like you can see towards the call. Probably there would be call to some other function. See, call to puts was given here. And second was after scanf, call to printf was given. Correct. So this is internal target used by the system, and it can decide whenever you don't have any formatting parameter included in the system. Now I'm not asking you to implement this, but I'm trying to show you what the system does internally to handle your function calls. Your function calls. Correct. Now, if I go above, And recall, I used some messages there. Enter number, square of percentage, percentage, and so on. So let us see how exactly they are written. See all of them, the three which I declared as a part of my data section. Actually, I haven't declared that as a data section because I wrote C code, but they are added internally by it into RO data, which is not going to change. Literal constant 0, local constant 0, local constant 1, and local constant 2. So if you keep adding such kind of messages in your code, ultimately you will see such variables would be created internally. Even your main, though it says function, but it adds something here as a local internally. Right? Let us try to see wherever exactly it is referring to the local values. See whether it is using LC0, LC1 or not. See this. So have you heard this term called GOT? Not Game of Thrones, by the way. In operating system, yes. In paging, probably while you were taught paging at that time, you must have heard this called our memory management. Global offset table, GOT. This LC0 is added into GOT of global offset table. Now this is a section of a program. When you say program, I mean to say executable or probably the library. It is used or it is added to hold address of functions which are dynamically linked. Okay, so let me add one link for you, probably which would be helpful. Now, I don't know whether how much grasp you have with your OS course, but at least try to see or follow the link that I have shared rather into the chat window now. And it will let you know like how exactly it is internally used whenever you are having a standard function call. Now, every book of operating system may or may not address these things in detailed manner, but this link probably can give you good idea about GOT and PLT, like procedure linkage table. Now let us assume that suppose this class is going on in a offline manner in the building of CS. Now, how will you verify whether it is your class? What would be your options? So either you are asking to a peon available outside. Where is my MSc class going on? Can you please communicate? Suppose no one is there. What would be your second option? You may enter in a classroom and suddenly you realize that it is not your classroom. Or it is not your class. Then you cannot jump out directly outside. Correct? You cannot directly jump out outside. How exactly you will handle such a situation? And that's the reason why you may require a class. You must or you should know, rather I can see here with your current students who are attending the class. Currently, I can see only 33 people are there apart from me. Now, if everyone is entering into the class, how you entered into the class? Because you were told this is the link of the class that you should join through. So for an offline class, you may have to know the schedule, who is the teacher, and so that you can definitely see the teacher at that time and then you can enter that class directly. So the code that you executed is generally called as stub, a function which resolves the call. Stub, S-T-U-B, plays an important. This is kind of function added every time whenever you are verifying with somebody. Suppose if I start, like you see me somewhere and you start talking about, it will take some amount of time because I haven't seen each one of you. It will take some amount of time for me to realize who exactly you are. So I suddenly will start executing in background my own programs. Okay, is he from second year? Is he from first year? Is he from computer science at all? Or is he the one who saw my YouTube video lecture about probably the extra credit courses? It will take some amount of time for me to really resolve that call. And that's the point where I will require something like this GOT. You have to give me reference. You are going to provide me a mechanism by which I would be able to connect with what you are exactly trying to communicate. Correct. And like in that case, what are the local variables are like in let us come back to what we were discussing. If we have local variables, then local variables would be prefixed with dot. Now you will see something like, for example, with mul %gs. So totally, like if you see when I see any operating system book rather. OK, so let me see if I can capture an image for you. One minute. Process this space. Now I'm picking it from, say, one of the Google by Googling. OK. OK, visit. Open image in new window. Yes. OK. Can you see my screen now? I assume.
Yes, sir.
Yeah. OK. This is what generally added into your OS book, any OS book, called as process address space. Now you may see it started from say 0 and then it is going somewhere here. For a code called hello, one program was written hello, which is an executable file. And for it, suppose it makes use of printf function and so on. Now how this area is allocated to it? So what happens is on a 32-bit architecture. OK, by the way, I'm addressing few things related to my operating system things as well, because you are requiring them to understand what exactly I'm trying to tell now. So your OS has different, your architecture has different registers that we talked about. Like we said, EX, EBX, ECX, EDX, ESI, EDI, ESP, EBP. Similarly, there can be some internal registers too. EIP, instruction pointer, flag register, eFlags, and so on. Moreover, it has segments. So by standard mechanism, there are stack segment, data segment, and code segment. 3 segments. your code would be distributed across these, and each one is having its own limited size. Say for example 64 KB. Each segment has 64 KB. Your code would be divided, your executable I mean to say, would be divided into different segments. Data would be added into data segment. Executable code would be added into code segment. And if at all a stack is used, which is not used by you, but used by the system internally to support your function calls, then stack would be added into stack. And that's what we say user stack created at runtime. That would be stack segment. Now, suppose if your code is very big. Now we saw that whenever our code gets loaded, code would be divided into set of pages. In operating system, some of you must have learned that one in your bachelor's. Your code would be divided into pages. Suppose if page size is 8 KB itself. How those pages should be loaded? So we assume there is a frame. Say 3 frames are. Every time you are going to load 3 pages. When you're a page not found and page is to be replaced, we have to make use of page replacement algorithm by generating page faults. Now suppose if my code goes beyond the segment size, 64 KB, like if my codes cannot be fitted into CS code segment, then the 32-bit processor of Intel adds few more segment values too, or segments, other segments are also added there, and they are given names as extra segments. Okay, now let me try to show you where exactly we can see them. So let me write simply this G. Let me remove this. Let us go to debugger. Breakpoint main, and let me simply say R and write info all registers. You can see code segment, stack segment, data segment, and ES, FS, GS are 3 extra segments added by the system for its own purposes. Okay, this ES, FS and GS. Extra segments are used by the system. And this is to be taken care of definitely by the system, and that's why you must have seen rather. Like when we talked about, not this one. Yeah, this one. We can see that it is referring to some extra segment value somewhere, which is from GS. Segment prefix is added there. Segment prefix. So if I try to see probably through the obj dump, try to see main. Dynamics tree, new version. The one which we saw earlier, whenever you have prefix like 16-bit data is there, so 66 is added, correct? So this is for the size, so that we will be getting now main. Yes. This 65 is meant for that segment override prefix. If you search into the manual, you should be able to see that because you are using another segment for this. This was the line. Correct. This was for move EAX A1. And this was 14, which is written as X because 0x14. That means 20 rather. Move EX, 20. But that 20 was picked from extra segment GS. And that's what it added there as a prefix called 65. So these are some internal adjustments the translator will be doing whenever it is trying to create your executable. And we know as a programmer, what kind of silly programs we do write. We never worry about system. Now, when I said silly, I mean to say just we do not worry at all about the memory space. Because we always assume that I have ample amount of memory available. Ample amount of memory is available with me and I can use it. But we have to always make sure that whenever we are talking about this ample memory, you are writing that code for yourself. But when you are working as a programmer for an organization, then definitely you have to take care of many major things. You cannot abruptly work out it that way. You cannot. You will have your own limitations. And you have to always think about how much memory space I'm having so as to load my code. So as to load my code. Any question till this? Are you with me?
No, sir.
If you have
No.
any questions, you can let me know. Others, please. Okay, from second week, rather, Abhijit will be starting his 3-4 sessions about Lex and Yak. Okay. I hope you understood what I tried telling to you. We'll try to address few more internal details of